Hey everyone, and welcome back to Stats and Stuff. Today we are going to take a look at some normal distribution problems and how to work them. Really just diving right in and taking a look at our four-step process and how it applies to these situations. So let's dive right in. So we're going to take a look at a couple here. If you haven't actually watched the video explaining kind of the four-step process, I'll put a link to it up above. But here we're just going to take a look at some straight out of a textbook normal distribution problems and see what they look like when we work them through. So we're going to look at this one right here, the 6.5. This is just a good basic example of the way that some of these problems work. So we're going to look at this one. Given a normal distribution with mu equals 90, again, that's the mean, and sigma, the standard deviation, is equal to 10, what is the probability that x is greater than 65, x is less than 60, x is less than 70, or greater than 110? So we want to come in and look at all of these kind of problems, okay? So to do that, let me move this out of the way, and we are going to then dive into the problem. So the first thing we want to do is really, let's just kind of write out some of our information here. Let me get over here. So we want to come in and say that mu is 90. Mu is 90. And sigma is equal to 10. Okay. Great. So with that in mind, we want to answer a couple of different problems. We'll start out with the first one. A is that x is greater than 65. Okay. So let's draw our picture. Okay. So again, that's step one of our four-step process, draw a picture. So I'm going to kind of make this a little big here. This is a normal distribution problem. So we draw the normal distribution. Doesn't have to look pretty, guys. Mine's not going to. Here in the middle is 90. Okay. And then we're going to label our x value. X is 65. And so we're going to draw a little line over here. And this is going to be 65. And we want to shade the area that we're looking for. All right. So I'm going to shade this in blue just so that it looks a slightly different color. We want to shade the area that's greater than 65. So that's this whole area over here, right? Including the area above 90. It's just everything greater than 65. Perfect. Okay. So now this is kind of starting the process. You know, point one, draw the picture. Always draw the picture. Step two is we want to turn our x value into a z value. And to do that, we're going to use our z-score formula, which is z is equal to x minus mu over sigma. Okay? So we're going to now plug in the values that we have for that. So x is 65. Mu is 90. Sigma is 10. And then 65 minus 90 is negative 25 over 10, which is equal to negative 2.5. So our z-score is negative 2.5. So what does that tell us? It's always just helpful to know what that means, right? Having a z-score of negative 2.5 is telling us that this 65 here is 2.5 standard deviations below the mean. All right, so it's pretty far down there. Remember, if you've kind of learned how far a standard deviation is, about 95% of all the area is within plus or minus 2 standard deviations. So 2.5 standard deviations to the left is a lot of standard deviations. Okay, so it's pretty far down there. So we would expect then this area to the right to be pretty big. It's always kind of helpful in the back of your mind to be thinking how big, just intuitively, how big is this area going to be? And in this case, we expect it to be pretty big, and we'll see if that works out that way. All right, so what I like to do is I like to come down here. I'm just going to write right here below 65 I'm going to say that z is equal to negative 2.5, just so it's down there. So 65 is equivalent to a z-score of negative 2.5. Now what we're going to go do is we're going to go look up in our z-table negative 2.5. Okay, so let's go look at our z-table here. Let me pull it over so we can all see it. Wow, you can see me through the z-table. That's kind of trippy. Okay, so we're going to go look up negative 2.5. Negative 2.5 is right here on the table. Again, this is showing us the area to the left. Okay, so negative 2.50, which is what we have, is 0.0062. 0.0062. That is the area to the left. So let's come over here, and we're gonna write this in. So the area to the left is 0.0062. Okay, now that is step number 3. We went and looked it up in the chart. That gave us the area to the left, and we wrote it onto our chart. Now, step number 4 is to come in and say, okay, use the area that we got out of the chart to find the area that we care about. Now, in this case, how do we do that? Well, we know the area to the left is 0.0062, but how does that help us find the area to the right? Well, the way that that helps us is we know that underneath this total curve, so in this entire area, it has an area of 1. Okay? So from infinity all the way to the left to infinity all the way to the right, the area under that normal distribution curve is 1. So the total area is 1. And I'm going to come over here and I'm going to shade this area that we found over here. Let's see if I can change my color real quick. Okay. This area that we found here in red. Okay. Just so that I can kind of talk about the blue and the red area. So if you added together the red area and the blue area, you get the total area. And we know the total area is 1, right? So we could come over here and write out on the side. We know that the blue area, which is what we're looking for, so let's call it X. So we know that the blue area, or we'll call it B just for the fun of it because it's blue. We know that B plus R is the red, is equal to 1. Okay, the blue area plus the red area is equal to 1. Well, the blue, we don't know what that is. The red, we do know what it is. It's 0.0062. And that has to equal to 1. Well, we can solve that. This is just then saying that blue is equal to 1 minus 0.0062. Right? And what is 1 minus 0.0062? So this area right here. Well, that's going to be 0.9938. So if you do 1 minus 0.0062, you get 0.9938. And that is the thing that we were looking for. So we'll circle it. If I can get my pen to work here. We'll circle it, and that's our answer. So that's how you solve one of these greater than problems. When you're looking for the area to the right, essentially what you are always going to do is you're going to come in, you're going to find the area to the left, and then do 1 minus that area to get the area to the right. Boom. It's that easy. All right. Now, let's go and take a look at another one of these problems. Let's see. Where'd my problems go? They're right here. Okay. Oh, look, an ad. Okay. Let's look at the next one. What's the probability that X is less than 60? All right. So let's go over here and let's see what the probability that X is less than 60. So again here, we've got let me right up here at the top. We know that mu is 90, and we know that sigma is 10. Okay, so then we want to find the probability. I guess it's B. Actually, it doesn't matter. We want to find the probability that x is less than 60. Okay, let's draw our picture. Always going to draw our picture here. Let's see, mu is 90. 60 is over here to the left. Again, doesn't really matter where you draw it on the left, just so far as, you know, things are in the right order. Okay, so let's, that's step one. Step one is draw the picture. Step two, calculate our z-scores. So let's come up here and say z is equal to x minus mu over sigma. Okay, what is that? So let's plug that in, and we get 60 minus 90 over 10, which is equal to negative 30 over 10, which is equal to negative 3. Okay, so our z-score is negative 3. So let's come down here and say z is equal to negative 3. So that is 3 standard deviations below the mean. Okay, and we're looking for this area right here. The area to the left, because it's the area less than 60. That's what we're looking for. So let's go look at in our z table. We know that our z table is going to give us the area to the left. That's what this table always does. So let's come back over here. Let's jump back to our z-score table. And we're going to go look at negative 3. Negative 3 has a z-score, sorry, has a area to the left of it of 0.0013. 0.0013. So let me write that over here. 0.0013 is the area to the left. Got that? That's step 3. Step 4, we want to come in and say, okay, using the area that we got out of the table, what is then the area? How do we use that to find the area here? It's the same area. So yay, this is our answer. So again, let's talk about what this means. Is that if you have a mean of 90 and a standard deviation of 10, there is only a 0.13% chance that you randomly will select an item less than 60. Okay, so very rare. Less than a 1% chance. 0.0013 is 0.13%. Very small. Okay. All right, let's work another one. Let's work one that is more applied, right? So let's pull this back up. Let's go back over here to our table. We're going to go down here to the more like applying the concepts one here, okay? So let's look at this first one. Ooh, it's a consumption kind of problem. So in 2014, the per capita consumption of bottled water in Spain was recorded to be 32.1 gallons. Assume the per capita consumption of bottled water in Spain is approximately normally distributed with a mean of 32.1 gallons and a standard deviation of 8 gallons. So right there, it's giving you the two things you need for the normal distribution. You need to know the mean. You need to know the standard deviation. That's the first thing we've got to identify, and it just gives it to us. The mean is 32.1. Standard deviation is 8. Okay? In fact, I'm going to go ahead and move this off to the side here. Well, we'll come back to it. All right. What is the probability that a person in Spain consumed more than 31 gallons of bottled water? Okay. So I'm going to sit that off to the side. Let's write out the information that we got. Okay. So we know that the mean was 32.1 gallons. He just gave that to us. and the standard deviation is 8 gallons. The question is what's the probability that a random person, X, consumes more than 31 gallons of water? Consumes more than 31 gallons of water. Well, it's probably that X is greater than 31. So we're randomly picking a person in Spain and saying, how much water do you drink? What's the probability that the amount of water they drink is more than 31 gallons? Okay, so let's draw our picture. You'll see this is going to be a really quick problem to work. This is 32.1. Here is 31. Wow, that's a wonky line there, isn't it? It's kind of going all over the place. And then we're going to shade the area that we want to find. I'm going to color it red here. And we want to find all this area over here, the area greater than 31. Okay? All righty. So how do we do that? Well, first we've got to turn 31 into a z-score. I can't go out and look up 31 on the table because 31 is not a z-score. 31 is just in this weird normal distribution we don't have a table for. So we've got to turn that into a z-score because we only have a z-table. So let's come over here and say z is equal to x minus mu over sigma. X is 31. Let's see, minus 32.1 over 8. So that is equal to negative, what, 1.1 over 8, which is equal to negative 1. Oh, I should have had a calculator ready, and I don't. Let's see, 1.1 divided by 8, 0.1375. Oh, yeah, that makes more sense. Let's see. So, see, this is why I always do the calculator. So come here, 0.1375. It's going to be negative. So now this is our z-score. I need to go look this up on the table. Now, our z-score table doesn't go out to 4 decimal points. It only goes to 2. So we need to round this to 2 decimal points. So this is approximately negative 0.14. The 7.5 rounds this 3 up to a 4. Okay? So this 31 is approximately 0.14 standard deviations below the mean. Okay? Fantastic. Now let's go grab our z-score table. Let's go look at it over here. And we need to find negative 0.14. So we'll come down here and go negative 0.1. And then we'll find the 4th column, which is here. And so the area to the left is 0.4443. Again, 0.4443. We're going to the negative 0.1 row and the 0.04 column. And so that's giving us the area to the left as 0.4443. All right. So let's now write that in. The area to the left is 0.4443. Great. Step number 4. We want to use that area to find the area that we care about. Well, we know that the red area over here, and I'll just draw kind of an arrow to it. We know that red area is 1 minus 0.4443. Because the total is 1, we take out the area we don't care about, and that leaves us the area that we do care about. So 1 minus 0.4443 is 0.5557. So what's the probability that if I randomly go find someone in Spain and ask them how much do they drink, if it's going to be greater than 31 gallons, there's a 55.57% chance that it will be. Okay. Let's work one more of these problems. Let's work one that we have to find some information in between. So we'll use this same example. Let's see, this one doesn't have any, so let's come down here. Here we go. Fly High Airlines determined that the distance traveled per aircraft per year is normally distributed. Great. With a mean of 60,000 miles and a standard deviation of 10,000 miles. What proportion of aircraft can be expected to travel between 44 and 54,000 miles in a year? So we'll work this one because this is an in-between problem, and that's one that we always want to take a look at. Okay, so let's come up here and let's write out our information. So mu, the average number of miles traveled, is 60,000. Now, we could write 60,000 here, okay, but everything in this problem is in the thousands, so it's totally okay if we just write 60. So the mean is 60,000. The standard deviation is 10,000. And we want to know what's the probability that x is between, let me write that a little differently, is between 44 and 54. So we're going to write it this way. What's the probability that x is between 44 and 54? All right, so let's draw our picture. Beautiful. Just beautiful. Should be in the Louvre. Okay. The Louvre? I don't know. I always just say Louvre. All right, the mean here is 60. We're going to find the area between 44 and 54. Now, both 44 and 54 are over here on the left. 44, 54, and we're trying to find the area in between. Okay? Now, how do we do that? We need to turn these into z-scores. And we got two values to turn into z-scores. So let's do that. So let's take our first z and say z1 is equal to, again, it's x minus mu over sigma, which in this case, we'll start with 44. It's going to be 44 minus 60 over 10, which is 16. So it'd be negative 16 over 10, which is negative 1.6. Okay. And now let's go up here and do Z2. Z2 is equal to x minus mu over sigma, which is 54 minus 60 over 10, which is going to be negative 6 over 10, which is negative 0.6. Okay? Great. Now what we want to do is we want to, let's go down, well, first thing we want to do is label these. So this one here is negative 0.6. And this one over here is negative 1.6. Make those points a little bigger so we can see them. Okay. So the question is really asking, right? We can restate the question now in terms of the standard normal distribution. We can say, what is the area? What is the probability that we get between negative 0.6 standard deviations and negative 1.6 standard deviations from the mean? Okay, that's what we really want to find out. That's what the question is inherently asking. So what we're going to do is we're going to go look up two areas. We're going to get an area to the left, and we're going to get another area to the left. If I can get my pen to work. So again, because we're looking up two areas, we're looking up two z-scores, we're going to get two areas. So let's go do that. Let's flip over to our z-score table. And let's look up, which one do we want to look up first? Negative 1.6. Negative 1.60 is going to be right here on the very front. So this very front is 0, 0, right? So negative 1.60 is 0.0548. 0.0548. So let's come back over here and we will write that in. 0.0548. I always have to say it out loud to myself like 1,000 times. 0.0548. Because if I don't, I will mess it up. So let's come to look at the next one, which is going to be 0.6 z-score, which has an area to the left of it of 0.2743. So let's write that in. 0.2743. So let's think about what this is saying. It's saying the area from this line all the way to the left is 27.43%. The area from this line all the way to the left is about 5.48%. So we want to find the area in between. So we're going to do similar to what we did earlier to find we said we're going to take the total area minus the area we don't care about. We're going to do the exact same thing here. We know this total area. So let me use a different color and we'll kind of shade it out. We know that this total area here, I'll shade it this direction. Right, can you see that? We know that total area is 0.2743. We know this area here, just this down here in the tail, is 0.0548. So what I'm going to do is I'm going to get rid of this area that we don't care about, and that's going to leave us the area with the white. So how do we do that? We just subtract. Let's come over here, and we're going to say that the area that we care about is 0.2743 minus 0.0548. Okay. And what does that give us? That gives us 0.2. Oh, let's see. I actually have to do math, you guys. So 3 minus 8. So 13 minus 8 is 5. This is then 3. So I need to carry that. So that's going to be 13. So that's going to be 9. That's going to be a 6. 6 minus 5 is 1. Sorry, I was doing the subtraction in my head. But what we end up getting is that 0.2743 minus 0.0548 is equal to 0.2195. And that is the answer to this area in the white shade that we're looking for. So let's just go ahead and circle that. I always like to circle it, make it easy to find. And that's the thing that we care about. So right there, we are looking at how to work these problems when they're not in standard normal distribution form to start off with. These are problems that are in just it's a regular normal distribution problem, and you need to follow that 4-step process to actually solve. Guys, I hope you really enjoyed walking through that, well, as much as you can enjoy walking through problems about the normal distribution. If you have any additional questions, leave a comment below. I'll be happy to help you out. Enjoy your time in your statistics class. Bye, guys.